NCERT Class 12th Chemistry Chapter 3 Electrochemistry YouTube channel PL Ready Chemistry JE NEET. Electrochemistry main topics: importance of electrochemistry, types of cells, types of conductors, galvanic cell and electrolytic cell, electrode potentials, Nernst equation and calculations, conductivity, molar conductivity and Kohlrausch law, Faraday's laws, batteries and corrosions. Electrochemistry Part 1. In today's class we are going to discuss about importance of electrochemistry, types of cells, types of conductors and galvanic cell and electrolytic cell. Electrochemistry. Electrochemistry is the branch of chemistry which deals with the study of production of electricity from energy released during spontaneous chemical reactions and the use of electrical energy to bring about non-spontaneous chemical transformations. See here, electricity is producing because of the spontaneous chemical reactions. By using the electricity, we can make a non-spontaneous chemical reactions also. This is the main thing in the electrochemistry. Importance of electrochemistry: electroplating, purification of metals, production of electrical energy, batteries and cells to bring out non-spontaneous chemical reactions, production of metals, non-metals and compounds, NaOH, like that. Now, conductors and types of conductors. First, we have to know that what are the conductors. The substances which are allowing electric current to pass through them are known as conductors. These are mainly two types: metallic conductors and electrolytic conductors. So, metallic conductors, we know that copper and silver, gold, iron, these are metallic conductors. Electrolytic conductors, generally all solutions which are ionizing, like HCl solution, NaOH solution, NaCl solution, those are. See here, metallic and electrolytic, the differences. In case of metallic, flow of electricity takes place, but in case of electrolytic, the flow of ions, electricity takes place with the decomposition of the substances. Generally here ions are present. Because of the ions, electricity is present, passing. Here because of the electrons. Next, conduction is due to the flow of electrons, of course given here. Then conduction due to the flow of ions. Then conductivity decreases with temperature. Conductivity decreases with temperature increases. While temperature is increasing, conductivity is decreasing, but in case of electrolytic, conductivity is increases with temperature increasing. Why? Because the mobility of ions also increasing. In this electrolytic solution, the conductivity depends on the ions mobility. Next, in the metallic, resistance offered by the conductor is due to vibrating kernels. Here kernel means valency shell before all electrons. Those are kernel electrons, except valence shell, remaining all electrons. Resistance offered by the conducting electrolyte is due to interionic attractions. Due to interionic attractions, resistance is generating in the electrolytic. That means if a compound is not ionized properly, that solution conductivity is less. Next, in the case of metallic, only physical changes takes place. In case of chemical, electrolytic, chemical changes takes place. Of course, physical also. In case of metallic, no movement of matter, but in case of electrolytic, movement of matter is there. Metals and graphite, these are the examples here. Here acid, base, all solution which are producing ions in that solution. Ions important. Of course, here the bigger ion move slowly, so conductivity is less compared to smaller ion. The key difference between Daniell cell and galvanic cell. Daniell cell uses only copper and zinc as electrode, whereas galvanic cell can have a variety of metals as electrodes. Daniell cell is specific. Actually, initially, the scientist, invented the cell with the help of zinc and copper electrodes. Now, electrochemical cells. Difference in galvanic cell and electrolytic cells. These are two types. Electrochemical cells, two types, galvanic and electrolytic. In the galvanic, electricity is producing. In the electrolytic, electricity is consuming. So external power is required. External battery we are using. So in case of galvanic cell, the chemical reactions are spontaneous chemical reactions. Those are producing electricity. In case of electrolytic cell, the chemical reactions are non-spontaneous reaction. By applying external force, we are carrying the chemical reaction. You can see one flowchart here. Electrochemistry, mainly two types of cells, voltaic cell and see this electrochemistry, voltaic cell and electrolytic cell. This voltaic cell, conversion of chemical energy to electrical energy. Chemical energy to electrical energy. See here, zinc rod dipped in the zinc sulfate, copper rod dipped in the copper sulfate solution. The electron flow is there from zinc to copper. We are not using any external forces. Due to the spontaneous chemical reactions, this electron, zinc is losing electron and copper is gaining electrons. So then electron flow is there, means of course that is only reason for electricity. Next, in case of electrolytic cell, conversion of electricity into a chemical energy. That means we are using external battery. By using the electricity, we are carrying some chemical reaction. Suppose if you apply external battery in case of fused NaCl, then we will get chlorine and sodium, like that. See here, the important thing is, in the voltaic cell, the electrode charges, very important. You have to remember this thing clearly. In case of voltaic cell, at anode and cathode, anode के पास oxidation reaction, at cathode reduction reaction. There is no change in the two cells about type of reaction. At anode always oxidation reaction, at cathode always reduction reaction. There is no exception in this. But the exception is only the sign convention of electrode. In case of voltaic cell, see that cathode is positive charge, anode is negative charge. How to remember? See, it is producing electrons. That's why it is negative charge. It is receiving electron, that's why it is positive charge. Copper is receiving electron. It is positive, that is the reason it is receiving electrons. If it is negative, obviously it will repel the electron. Like that you can remember easily. Next, in case of electrolytic cell, the battery is important here. The battery negative terminal attached electrode is negative charge, that is cathode. positive terminal attached electrode is positive charge, that is anode. At anode, oxidation reaction, at cathode, reduction reaction. This is the common in both cells. Electrochemical cells. Difference in galvanic cell and electrolytic cell. We can see some points here. In the galvanic cell, chemical energy is converted into electrical energy. This is the main point here. Electrical energy converted into chemical energy in case of electrolytic cell. Anode, negative electrode, cathode is positive electrode. Of course here opposite. Anode is positive electrode, cathode is negative electrode. Next, ions discharged only on the cathode. Here ions discharge on both the electrodes. This point, because here battery is there, battery producing one side positive charge, one side negative charge. So at anode, oxidation reaction, at cathode, reduction reaction. So two sides. You can see the figure again. See here, at anode, what are the anions going and discharging at positive charge, and cation goes to cathode and discharging that charge, receiving electrons, forming neutral. In case of electrolyte, at two electrodes forming neutral particles. In case of left side voltaic cell, anode, at anode forming anion, zinc plus 2 is forming. See here reaction, you can see zinc is forming into zinc plus 2. So here there is no neutral particle, but in case of copper plus 2 forming copper at cathodic cell. So only one side is neutral particles are forming, the other side forming ions. Next, concentration of the anodic half cell increases while that of cathodic half cell decreases when the two electrodes are joined by a wire. Concentration of the anodic half cell increases while that of cathodic half cell decreases. Obviously, the zinc is forming into zinc plus 2, so concentration is increasing. In case of copper electrode cell, the copper plus 2 ions are forming into copper. After some time, the number of copper plus 2 ions are decreasing, so the concentration also decreasing. Then electrodes are fitted in different compartments. You saw that figure. In case of electrolytic cell, electrodes are inert. Concentration of the electrolyte decreases with electric current is circulated. Initially more number of ions are present, then while electricity is passing, the electrolyte is getting deposit. Then both the electrodes can be fitted in the same compartment. दोनों के बीच में there is no separating. Note, anion goes to anode undergoing oxidation, cation goes to cathode undergoing reduction. The direction of current flow is opposite to that of electron flow. See here, this is the thing. Electron flow and current flow is quite opposite direction. See the simple Daniell cell. Daniell cell means zinc rod dipped in the zinc sulfate, copper rod dipped in the copper sulfate solution. When we are making this simple cell is connected with wire and voltmeter. The voltmeter showing that 1.1 volt. Of course, the concentration of the solutions is 1 m. All are at standard conditions. What are the standard conditions? 1 atmospheric pressure and room temperature, and concentration is 1 m. In that case, we can observe that 1.1 volt battery we can make it. So here the copper is positive charge, zinc is negative charge. Why? Because zinc is getting oxidation and losing electrons. These electrons are, see, these electrons are going into the circuit. So copper is receiving these electrons. So the power, electricity, the current direction is like this. This is the I direction. ठीक. Now the important thing is here salt bridge. So this salt bridge is necessary to keep. If we don't keep the salt bridge, there is no further reaction. See here, the in case of right side here, oxidation cell, the zinc is converting into zinc plus 2. After some time, so many zinc particles will be forming, all zinc particles. Okay. So this total cell becomes positive charge, positive charge, positive charge. At the same time, the left side, these are taking electrons. This copper plus 2 is forming copper. Then so many sulfate ions are there. The sulfate ions are negative charge, negative charge, negative charge. This complete cell becomes negative cell, negative charged cell. The right side is completely positive charged cell. If the charge is accumulated, then the further reaction will be stopped. To avoid this problem, we are using salt bridge. In the salt bridge, salts are present. Suppose here sodium sulfate is there. In the sodium sulfate, actually we are keeping in the agar or Al2O3 alumina. We are filling in this tube. Then we are keeping this sodium sulfate solution. So wherever the ions, which ions are required, those ions dissolving in that respective solutions. See here, sulfate negative charge is more, so positive charged particles required here. So only Na plus ions are dissolving here. Here required sulfate ions. So sulfate ions are dissolving here and forming zinc sulfate is forming here. Here it is forming zinc sulfate. Here it is forming copper already settled down, SO4 minus 2. Many ions are there. Na is coming. So Na to SO4 is forming here. Here it is forming Na to SO4. So there is no further charge accumulating in the half cells. Questions? In galvanic cell, at anode, what type of reaction takes place? See, in any cell, at anode means oxidation reaction takes place. There is no exception in this. Okay, anode means oxidation, oxidation reaction. Next, difference between electrolytic and galvanic cell. Electrolytic, generally liquid cell, of course, electrolytic and galvanic. In the galvanic, electricity is producing, and electrolytic, electricity is receiving. Okay. In the galvanic, spontaneous chemical reaction takes place. In the electrolytic, non-spontaneous chemical reaction takes place. Next, what is the sign of anode in electrolytic and galvanic cell? Electrolytic and galvanic cell means sign of anode. See, in case of Daniell cell, that is a galvanic cell, zinc and copper electrodes are there. The zinc is producing electrons to copper. So this is the negative charge, this is the positive charge, because it is taking electrons, copper. So now the question again, what is the sign of anode in electrolytic and galvanic cell? This is the galvanic first of all. In case of galvanic, zinc is anode. Okay. So the charge is negative. If you understand this concept clearly, then automatically you can answer it. Electrolytic. In electrolytic cell, the anode has positive charge. Galvanic and electrolytic both are quite opposite charges. Can we store zinc sulfate in iron container? Zinc sulfate in iron container. You can see here zinc sulfate and zinc sulfate plus iron. Which is a more reactive? So iron is more reactive. So already iron is +2. So sorry, zinc is more reactive. Zinc is already +2. So according to displacement reaction, highly reactive metal can displace low reactive metal ion from its salt solution, but this iron cannot displace. Iron is less reactive. So can we store zinc sulfate in iron container? Yes. Yes. Answer is yes. Next, what is the functioning of salt bridge in galvanic cell? Already we discussed that in galvanic cell, to neutralize the charge in both cells, we are using the salt bridge. Or any other salt, that is the main purpose. Next, which of the following will not conduct electricity in aqueous solution? Which is not producing ions, those will not conduct electricity. So that is the sugar. Copper sulfate is producing, common salt also producing. So sugar is not producing any ions. Next, an electrolyte. This is the answer B here. An electrolyte forms a complex ions in solution, gives ions only when electricity is passed, possesses ions even in solid state, gives ions only when dissolved in water. When dissolved in water, of course it is giving, but that possess ions even in solid. Even in solid also, those are in the form of ions only. Forms complex ion in solution. Complex ion solution तो नहीं है, वो dissociate होता है, so wrong है. Gives ions only when electricity is passed. ऐसा कुछ नहीं है, even in the water also it is producing ions. Possess ions even in the solid state, yeah, true. Gives ions only when dissolved in water, तो normal में भी देते हैं. Next, current and electron flow direction in galvanic cell is, so opposite direction is the one answer. Otherwise we can say galvanic cell na, if it gives the Daniell cell, we can give some more explanation. That is zinc to copper is the electron flow, then copper to zinc is the electricity. Copper to zinc is current, we can say. ठीक है, this is the thing. Okay, next class is electrode potentials. Thank you. Don't forget to like and subscribe the channel. Lingareddy, Pisati.